Hello mga ka-e-study! Today we will discuss about the exponential decay model for the selective radioactive substances, and we will predict the amount left after the given time. So, what is a radioactive substance? Radioactive substances are a group of compounds that have unstable atoms at the nucleus. They become stable by altering their nucleus, a process known as radioactive decay or transformation that frequently results in the emission of ionizing radiation. So today's discussion, we will be talking about the exponential decay model of the radioactive substances of plutonium-239, iodine-131, and strontium-19. The first substance is the plutonium-239. The plutonium-239, or Pu-239, is a radioactive substance that serves as fuel for both nuclear weapon blast and reactor operations. In short, it is used to make nuclear weapons. Since it is a radioactive substance, one of its major effects in our health is it can lead to lung disease and cancer due to the alpha particles. This substance has a half-life of 24,110 years. So for our first given, we have plutonium. Plutonium have 239 radioactive with a half-life of 24,110 years and an initial amount of 350 grams. What is the remaining amount after 25 years? So in exponential decay, we have the formula of y equals AB over x. And we will substitute our given values, which are 24,110 years, 350 grams, and 25 years. After the given was substituted, it will be y equals 350, open and close parenthesis, 1/2, x slash 25. And now we can solve it. After being solved, the answer of the remaining amount must be 349.99 grams. So after 25 years, the remaining amount was 349 grams left. Great job! And now let's move on to our second given, the iodine-131. This substance is used in pharmaceuticals and disinfectants, printing inks, and dyes. Although high iodine intake can also cause thyroid gland inflammation and cancer. Iodine's radioactive substance or decay rate is 131. The radioactive substance is characterized by time parameters. It has a half-life of 8 days and initial amount of 300 grams. It was multiplied by the years that resulted in 46.87 grams by using an exponential decay model. A is the initial amount of substance B is 1/2, and x is the number of days over a half-life, wherein y is equals to AB over x. Thus, y 300, open and close parenthesis, 1/2, x is equals to 8. Finally, the last radioactive substance that we will discuss, the strontium-19. Strontium-19 is used in manufacturing of color televisions, picture tubes, used in making ceramics, glass products, fluorescent lights, and other products. The negative effect of strontium is when taking a high level of strontium can damage the bone marrow and causes anemia and prevent the blood from clotting properly. Now let's consider our given scenario. Given the strontium-90 with a half-life of 29 years and an initial amount of 450 grams, what is the remaining amount after 13 years? So we're just going to repeat the process wherein we'll still use the formula wherein y is equals to AB over x. And substitute our given values, which are 29 years, 450 grams, and 13 years. After the given was substituted, it will be y is equals to 450, open and close parenthesis, 1/2, x over 29. And we can now solve it. After being solved, the answer must be 225.47. If you get the same answer, then your solution is right. So after 13 years, the amount was 225.47 grams left. I hope you learned something new about the exponential decay model of radioactive substances, and always remember that radioactive substances are a group of compounds that have unstable atoms of the nucleus. They become stable by altering the nucleus, a process known as radioactive decay or transformation that frequently results in the emission of ionizing radiation.